In this lecture, we'll talk about solving systems of equations with this example first. The first equation is 5x minus 4y plus z equals 0. The second equation is x plus y equals z, and the third one is negative 20x plus 16y minus 4z is 0. To simplify this system, we want to multiply the first equation by 4 everywhere. Okay. Then we know 4 times 5 is 20, and we add times 4 to the first equation, and we add onto equation 3. You can see down here what I wrote is equation 1 multiplied by 4 and added to equation 3. Okay, multiplied by 4, what do we get? You see down here that will be what? 20x negative 16y and then 4z equals 0. Okay, equals 0. 4 times 0 is 0. And then if you add to the third equation, you have is they all cancelled. You see that? Okay, 20x here is negative. Negative 16y, positive 16y. 4z, positive, negative 4z. Okay, so then what we get will be the third equation is actually disappeared. So if it's 0 equals 0, we don't write that. So basically this system is simplified to 5x minus 4y plus z. That was the first one. And then the second one is x plus y equals z. And the third one does not exist anymore. Okay. All right. Now, then we got is the system of two equations. Now, here we want to eliminate the x in the first equation. Then we do is the second equation multiplied by negative 5 everywhere. Then what do we get? We get negative 5x, negative 5y, negative 5 times 0 is 0. Okay, so what we did right here is that equation 2 multiplied by negative 5 and add to equation 1. So here is negative 5x, add on that, those two cancelled. Negative 5y add to negative 4y, you have a negative 9y. Okay, and then there is no z, so we still have a z equals 0. Alright, then from here we have is negative 9y plus z is 0, so both sides subtract subtract z. You may cancel positive z right here. Okay, right here. So then it comes to what? 9y negative equals z plus negative z. So 0 plus negative z, so it's negative z. So you have a negative 9y equals negative z. Okay, then both sides divided by negative 1. You then cancel, this is negative 9 divided by negative 9 is 1. 1 times 1 is 1. And negative z divided by negative 9 is z over 9. Okay, so y is expressed by z. Now, similarly, we can do the thing is that equation 2 may multiply it by 4. So equation 2 is multiplied by 4. 4 times x is 4x. 4 times y is 4y. 4 times 0 is 0. And then we add to the equation 1. Add to the equation 1. Then you know here is 4y. Here is negative 4y. They cancel each other. And here is 4x plus 5x. So what you get is 9x. And those two cancelled. And then you have a z left. And then 0 plus 0. So you have 9x plus z. Now, both sides subtract z. You may get those two cancelled. Okay. You then have a 9x equals negative z, because those two cancelled. 9x left over on the left. And 0 minus z is negative z. Okay, and then divided by 9. And you can see negative 9 upstairs, 9 downstairs. Then you have a 1. 1 times x, you have an x. And then here is negative z divided by 9. So you have a negative z over 9. Okay, so x is also expressed by z. You know, that will be the solution for x. Because, you know, down here, z can choose many different values. For example, if z is 9, 9 divided by 9, we have a 1. And 9 divided by 9, here there is a negative, so you have a negative 1. Okay? So when z is 9, x is negative 1, and y is 1. Okay? You see, if x is negative 1 and y is 1, and then you know negative 1 plus 1 is 0. Okay? And up to here, x is negative 1, and you can see negative 1 times 5, you have a negative 5. And y is 1, 1 times, y is 1, 1 times negative 4, you have negative 4. So you see negative 5, negative 4 together is negative 9. And z was 9. So 9 plus negative 4, and then negative 5, you have a 0. That's one solution for z equals 9. But you know z can be 18. Then you get what? X is negative 2, and y is positive 2. And z is 18, you put here, is also going to work. And z, you know, can be what? Can be 27. Okay, yeah, so in this case that z is called free variable. Okay, we didn't say that in the book, but z is like free variable. Okay, it can be anything. All right, and then you know, then if z changes, x, y changes. So in this case, the equation has infinitely many solutions. The equation, maybe you want to say the system of equations has infinitely many solutions. Okay, so that's the solution for the system. Ready? Okay, I'll see you next time.